Okay, 3.4, graphing exponential functions. Students be able to graph exponential functions. So we're going to do a little bit of interpreting graphs first and being able to write the functions. So exponential functions have the following form. It's this guy right here. So that you could say f of x, or remember f of x is just the same thing as y, equals ar to the power of x. So that's what defines an exponential function, is that the x value is actually in the exponent. We call a our initial value, and we call r our common ratio. Initial value meaning that's where this thing started at. So that's actually when x is 0, that's our y value. It's the same thing as whatever a is. So how can we do this? Well, it says right here initial value is 5. Well, remember that's the a, and that your common ratio is r. So all I want you to be able to do here is to write the function, and they say function h of t. So since this is h of t, I'm going to write a, which they said our initial value is 5, so a times r, which is 1/2, to not the power of x this time, because they're telling me that this is a function of t, so to t. And that's it. Now I've written that function. Okay? Next thing says write the function of g of x. Okay, so I want you guys to go ahead and try this. They give you the initial value, they give you the common ratio. Go ahead and use the form to write the function. And then pause the video when you're ready to check your work. Okay, so you would write g of x equals, and then you'd write your a value, and they actually tell you your a value. It's the initial value. It's right here. It's 1/3. So I'd say 1/3. Parentheses, what's the common ratio? Well, they tell me that that's 4, because the next thing is the r, so that's 4. And then 4 is being raised to the power of, and this time it is a function of x, so yes, you can put an x there. Okay, so now you've written the function that they're describing. Okay, so that's step 1. Now, we're going to do the same thing here, where they give us some graphs, okay? They give us some graphs, so they don't give us the a and the r now, they just give us some graphs and they want us to interpret this. Well, they're actually giving us enough information to write the functions, because that's what they want us to do, write the exponential functions. If you notice, they give us a little bit of information. I can make a t-chart out of what they give me, so I'm going to do that. So if I had x and f of x, I'm just using this border as my t-chart, I know two things. I know that when x is 2, because this is my x line, f of x, or y, is 3. So let's put that in my chart. 2 and 3. And then I also know that when x is 3, f of x is 1. The height is 1. So I put that in my chart. 3 and 1. Okay, this is important because I can plug these values into my equation and get two equations. Let me show you what I mean. I know that I can plug in f of 2, which equals 3, right? So if I plug in a 2 for f of x, it gives me 3. And I also know that this is going to equal this function, a r to the 2. Okay. And I can plug in another function. I'll do this one in blue. I also know that f of 3, so when I plug in a 3 to the function, I get a 1. So I can say this equals 1, which is going to be a r to whatever my x value was, and my x value was 3. Okay, so there's a few different ways we can manipulate these formulas now to get our a and r values, but I want to show you the way that just pretty much always will work, and this is called using systems of equations. So I'm going to write out these two equations side by side. So I first have f of 2 equals 3 equals ar squared, and actually you don't need that part for right now. And then I also have 1 equals ar to the 3rd power. Alright, what I can do here is I can plug in, I could solve for one of these variables, either a or r, and plug it into the other one. Now I notice that r has a exponent of 2 here and an exponent of 3 here, so that's not going to be the simplest one to solve for. But a doesn't have any exponents on either one of these, so I think that's going to be the simplest one to solve for. And this one just has a 1 in it, where this one has a 3 in it, so I think I'm going to use this equation. So let's just solve for it. Well, I'm going to divide both sides by r cubed, divide by r cubed. That cancels out over here, and yeah, I have a then is equal to 1 over r cubed. Well, I can then take this a value and plug it in for a there. And so I'd have a new equation. It would be 3 equals, instead of a, I could write 1 over r cubed times r squared. Alright, well, I can simplify this a bit. This means that I can put the r squared on top, so this really looks like 3 equals r squared over r cubed, which is really like saying 3 equals 1 over r. Alright, so I can solve for r here. I could do that by multiplying both sides by r, and then I would get 3r equals 1, and then dividing both sides by 3. And I get r equals 1/3, because these guys would cancel out. Alright, so just a little algebra, and I was able to solve for r. Alright, now that I've solved for r, I can plug that value back in over here where I've already solved for a and figure out what my a value is without any variables in it. So let's go ahead and do that. So remember, my r is 1/3, so I'm going to go over here. So that means that a equals 1 over 1/3 cubed. Well, that equals 1 over 1/3 cubed is 1 over 27. And what you really have here is a 1, I could call it 1 over 1, divided by 1 over 27. So that means I can multiply by 27 over 1, and this is really just 27. Okay, so got to get used to a little bit dealing with fractions, but remember that you can always flip and multiply when you're dividing fraction by fraction. So my a value is 27, which now if I go and look at my graph, remember that my a value is my initial value. That's where it would start here on the y-axis, and yeah, it sure looks like it could be way up here somewhere by where 27 is, so that makes sense. So now we can actually write our equation in the form that they originally give us, plugging in what we know our a value is and what we know our r value is. So we get f of x equals, the a value we found was 27, the r value we found was 1/3, to the x power. And by the way, this means that it's going down 1/3 for every x, and that makes sense as well, because look, when x was 2, we had a height of 3. That means if I went over 1, I should have 1/3 of the height, which I do. I have a 1. So see how we got that information? Now, there are some other ways that you can solve this, but they don't always work, okay? So I really wanted to show you this whole pattern of being able to use systems of equation, where you solve for one variable, hopefully the simplest one, and you plug it into the other, solve for the other variable, and then plug it back into the first one that you solve for. And that's how you can get both your r and your a value, okay? Now, on the next one, I want you guys to try it on your own, but this one is actually quite a bit easier because you can start off knowing your a value. Remember, your a value is whatever this graph hits, okay? Whatever it hits when x is 0. Well, when x is 0, the height is 32, so you actually start off knowing your a value on this one. Just by looking at the graph, it's 32. Your a value is essentially the y-intercept, okay? So you know the a value. Now you just have to find the r, and you can use this point right here, which was when x is 3, that y is 4, to solve for it. So I want to let you guys go ahead and try that. Pause the video, and then I will put my work up in just a little bit. Okay, well, hopefully you gave it a try. I'm just going to walk you through this a little bit. So I first just wrote the function out, g of x equals 32r to the x. I put in the 32 for a, since I already know that's my a value, my initial value. And then I also know that when x is 3, the function is 4, or y is 4. So I went ahead and said g of 3 equals 4. So I can use that information to plug in to my function. I know that g of 3 equals 4, so I can write g of x is 4 when 32 are, and the x value is 3, right? Because this is like my x value, this is like my y value, so I just plugged it all in. Well, I could do a little bit of algebra here and solve for r, so let's go ahead and do that. I'm going to divide both sides by 32, divide by 32. That gives me 1/8 equals r cubed. Okay. Well, now we have a situation where we have a variable to an exponent, but it's not the square anymore. Now it's a cubed. So this is where we have to use those things that we were learning about earlier. We have to use the cubed root. And your calculator has this function. It can do it, but we can kind of do this in our head. The cube root of 1 is just 1 because 1 times 1 times 1 is 1. So it's the cube root is just 1. So the top of this is going to be 1. So now we just need to figure out what's the cube root of 8. And this is not that bad, actually. The cube root of 8 is one that you should probably have memorized, because we could go over here with some side work. Isn't 2 cubed, doesn't that equal 8? So therefore the cube root of 8 must equal 2. Right? Because 2 times 2 is 4, times another 2 is 8. So the cube root of 8 is 2. So we could just write 2. And then these guys cancel each other out. The cube root and the cube just make, they just cancel each other out, so it just makes r. So my r is 1/2. Alright, well, now you have all the information you need to write the function. So you can just write g of x equals, your a value is 32, your r value is 1/2, and the x goes up here as your exponent. Boom, there you go. Hopefully that's what you came up with, and that should actually make sense. That means that this function should go down by 1/2 for every x value. So we start at 32, so that means half of 32 is 16, so at 1, yep, 16. Then at 2 it should be half of 16, which is 8. 2 is at 8, yep. And then at 3, then it should be half of 8, which is 4. And if we were to keep going, at 4 it should be at 2, and yes it is. See, so it follows that pattern, so we know that this is working exactly like it's supposed to. Okay, so now that we've interpreted some graphs and we've written some functions finding the a value and the r value, we should be able to graph these guys now. So I gave you a little bit of instructions on how to do it. It says plot the initial value and then one other value on the graph, then sketch the function. So we only need to graph one other point. This isn't too bad. Pretty simple, actually. We know what the initial value is. It's this number all the way over here. Remember the a value. Again, our form is simply f of x equals a r to the x, where this is our initial value. So our initial value is 8. Okay, well, then that means I'm just going to come over here and find 8 along my y-axis. 1, 2, 3, 4, 5, 6, 7, 8 is right there. So there's my starting point. All right. And I can actually just kind of look at this graph and see what's happening. It's going down by 1/2 for every x value. That's what we're doing. We're going to multiply it by half for every x value. So I should go over 1 and then cut it in half, and then over 1, cut it in half again, over 1, cut it in half again. So we should have something that looks kind of like that. But we can also just test this. We could say, you know what, let's make a little t-chart, x, f of x. And we could plug in a 1 for x. We could plug in a 2. We could plug in a 3 and see what we get. Well, if I plug in a 1, I have 1/2 to the power of 1, which is just 1/2. So I just have 1/2 of 8. Well, half of 8 is 4. Pretty straightforward. Okay, that's easy. What if I plug in a 2? What if I made this a 2? Well, what is 1/2 to the second power, or 1/2 squared? Well, it's 1/4. So rather than kind of work this all out a little slowly with you, I'll just show you. F of 2 would equal, that's a 2 in there, would equal 8 times 1/2 to the second power. That equals 8 times 1/2 squared is 1/4. And 1/4 of 8 is 2. So I could say that F of 2 is 2. So I can write over here, that's 2. Okay, let's do one last one. Let's do 3. So let's figure out what F of 3 is. Well, that would be 8 times 1/2 to the third power. Okay, well that equals 8. 1/2 to the third power is going to be 1, because 1 to the third power is 1, and 2 to the third power is 8. So I have 8 times 1/8. Well, what 1/8 of 8 is just 1. So f of 3 is 1. So that means when I plug in a 3, it gives me a 1. Well, now I have enough points in my table that I can graph. And couldn't I use a graphing calculator to come up with these points as well? It's really not a complicated idea, but it's pretty simple math here. I didn't do too complicated math. It's not like a big crazy polynomial. So let's go ahead and plot this. At 1, I'm at 4. At 2, I'm a height of 2. And at 3, I'm a height of 1. Okay. It's a pretty good sketch of the graph. It's going to look something like that. And that's it. Okay. Now, it said just plot the initial value and then one other value. But I did a few other values just to be a little bit more accurate, and I think that's a good idea. So I would try a few just to see what you can, and it helps you just graph a more accurate graph. And if we think about this, I knew that this thing was going to never go lower than 0, because if I keep cutting these numbers in half, they'll get smaller and smaller and smaller. Like half of 1 is 1/2, half of that is a 1/4, and half of that's an 1/8, and so on and so on and so on. So these numbers are going to keep getting smaller and smaller and smaller, but they're never going to become negative. Just by cutting a value in half, it'll never be negative. So it's going to keep going along this line forever and ever and ever, getting really, really close, but never actually going below it or touching it. So I want you guys to try this one. You have the initial value, you have the common ratio, you can see how it's decreasing, you can kind of get an idea of what the function looks like, but go ahead and try making a t-chart and working it out, and then unpause the video and you can check your work. Okay, I just want to point out the first thing I saw is that my initial value is 9, so my a value is 9. So I went ahead and graphed that point right there at a height of 9. So on the y-axis, I knew my graph was going to be touching 9. From there, I just made a table, x and f of x. So I plugged in a 1. What happens when I plug in a 1? Well, if I plug in a 1, 1/3 to the 1 is just 1/3, and 1/3 of 9 is 3. So I knew that my height is 3, so I went over 1, up 3, and plotted that point. Then I thought, oh, well, why don't I plug in a 2? So I plugged in a 2. So I got 9 times 1/3 to the second power. 1/3 to the second power is 1/9, because 1 squared is 1, and 3 squared is 9. Okay? So 9 times 1/9, well, 1/9 of 9 is just 1. So that means when I plug in a 2, I get a 1. So over 2, up 1. Now if I plug in any more values, they're going to get really small fractions. So I just kind of estimated where the line is going to go from there. And again, it's not going to ever go below 0 here, right? Because there's nothing I could plug in here. Even if I plugged in 100 here, I'd get a really, really small fraction, and I have a really small fraction of 9, but I wouldn't get a negative number. Right? It would just be positive. It'd be some really tiny number just right above the 0 forever and ever and ever. And there we go, I've graphed it. So that's how we graph exponential functions, and I'll see you guys on the next video.